Hey everyone, welcome back to the channel. In today's video, we're diving into the object pool design pattern in Python. If you're looking for a way to manage and reuse objects efficiently without creating new ones all the time, this pattern is perfect for you. I'll explain how the object pool pattern works, why it's useful, and how you can implement it in your Python projects. So stick around and let's get started. 1. Introduction. The object pool design pattern helps manage the reuse of objects by maintaining a pool of pre-created objects that can be reused instead of creating new ones each time. It's especially beneficial when object creation is expensive as it allows better resource management by recycling objects that are no longer in use. This pattern efficiently balances object creation and reuse, improving performance and resource allocation in systems where many objects are needed repeatedly. Key characteristics. The object pool design pattern allows objects to be reused rather than be created, optimizing system performance by minimizing the overhead of object creation and destruction. It manages resources efficiently by maintaining a pool of pre-created objects, ensuring they are reused as needed. The pooling mechanism retrieves objects from the pool when available, creating new ones only when necessary, which helps maintain resource control and prevent excessive object creation in the system. 2. What is the object pool design pattern? The object pool design pattern helps manage the reuse of resource intensive or frequently used objects by maintaining a pool of pre-created objects. Instead of creating new objects every time they're needed, the pool provides an available object, and once it's no longer required, it's returned to the pool for future use. This approach improves efficiency and reduces the overhead associated with object creation, especially in scenarios where creating objects is costly or time consuming. Real world analogy. Imagine a library where instead of buying new books for every reader, people borrow books, read them, and return them for others to use. In software, the object pool design pattern follows this concept by managing a pool of reusable objects so new instances don't have to be created every time. This pattern improves efficiency by allowing objects to be reused, just like how books in a library are shared among readers. 3. Why use the object pool design pattern? The object pool design pattern is ideal for situations where creating objects consumes significant resources like managing connections or large instances. Instead of frequently creating and destroying objects, the object pool keeps reusable objects, minimizing the overhead of repeated instantiation. By maintaining a pool of available objects, the object pool pattern boosts efficiency, improves performance, and manages resources effectively. It supports scalability by ensuring that commonly used objects are always ready, reducing memory usage and response times in demanding applications, making the system more responsive and cost effective. 4. How to implement the object pool design pattern in Python. The object pool design pattern in Python involves creating a pool that manages object creation, reuse, and recycling. This is particularly helpful when creating objects is resource heavy and you need to control the number of active instances. Instead of creating a new object every time one is needed, the pool provides an already created object, improving efficiency. When an object is no longer needed, it's returned to the pool ready for reuse, minimizing resource consumption while maintaining flexibility and performance. Step-by-step implementation. In this example, the object pool design pattern is demonstrated. This pattern is used to manage a limited pool of reusable objects, allowing objects to be shared and used efficiently rather than creating new instances every time one is needed. The object pool pattern is particularly useful in scenarios where object creation is resource intensive or expensive, such as managing database connections, threads, or in this case, reusable objects. The reusable object class represents an object that can perform an operation, e.g., do underscore something. Each instance of reusable object is assigned a unique ID when created. The object pool class manages a pool of these reusable objects. It has a max underscore size attribute that defines how many objects can be in use at any given time. The pool list holds available objects that are not currently in use, while the in underscore use list tracks objects that are currently in use. The get underscore object method in the object pool class either retrieves an available object from the pool or creates a new one, if the maximum pool size has not been reached. If the pool is empty and the underscore use list has reached its capacity, it raises an exception indicating that no objects are available. The release underscore object method releases an object back into the pool after use, making it available for reuse. In this scenario, two objects are retrieved from the pool using the get underscore object method and perform an operation via the do underscore something method. After the first object obj1 is released back to the pool using release underscore object, it becomes available for reuse. When the next object is requested, instead of creating a new one, the pool provides the same object obj1 that was previously released, demonstrating object reuse. This pattern helps conserve resources by limiting the number of objects that need to be created and managing object lifecycle effectively. Instead of continuously creating and destroying objects, the object pool pattern ensures that once an object is no longer in use, it is returned to the pool for future reuse. This improves system performance and resource management, especially in environments where object creation is costly or frequent. Referring to earlier examples, this pattern ensures efficient resource handling by keeping track of object usage and minimizing unnecessary instantiation, making it ideal for systems that deal with high frequency object creation or resource intensive operations. 5. Real world use case object pool pattern in action. 1. Database connection pooling. In high traffic applications, managing database connections efficiently is essential to ensure smooth performance. The object pool design pattern helps by creating and managing a pool of reusable database connections which multiple clients can share. Instead of creating new connections for each request, the pattern allows clients to borrow an existing connection from the pool and return it when done, optimizing resource usage. This approach ensures faster response times and reduces the overhead of repeatedly establishing database connections. Why object pool design pattern? The object pool design pattern is especially useful for managing expensive to create resources like database connections. Instead of repeatedly opening and closing connections, the pattern allows for using a fixed number of existing connections, minimizing overhead. This helps efficiently manage resources by keeping only a limited number of active connections at a time, preventing database overload. By using connections from the pool, the system can handle many simultaneous requests, improving both performance and scalability without creating new connections each time. Expanded use case. Imagine a web application where many users need database connections at the same time. Instead of creating a new connection for each user, an object pool manages these connections, making the process efficient. When a user finishes, the connection goes back to the pool ready for another user, reducing the need for constant connection creation and closure. This approach helps the application scale efficiently, cutting down on overhead and conserving resources. Practical implementation. In this example, we see the object pool design pattern in action, which is a common technique used to manage set of reusable objects such as database connections. This pattern is particularly useful when object creation is resource intensive or when there is a fixed number of objects available, as in the case of database connections, network sockets, or thread pools. The database connection class represents a database connection with a unique connection underscore ID. It simulates connecting to and closing a database using the connect and close methods. The key element here is the connection pool class, which acts as a pool manager that limits the number of active connections. Instead of creating a new connection each time one is requested, the connection pool pre-creates a fixed number of connections defined by max underscore connections. These connections are stored in a queue and clients can retrieve and release connections as needed. The get underscore connection method is responsible for returning an available connection from the pool. If all connections are in use and the pool is empty, it informs the client that no connections are available. This prevents the system from overloading itself with excessive connections. The release underscore connection method is used to return a connection back to the pool once it is no longer needed. This ensures that connections are used rather than discarded, improving both performance and resource efficiency. In the usage example, 3 connections are successfully retrieved and used. However, when a fourth connection is requested, the pool is empty and no connection is available, demonstrating how the pattern prevents overuse of limited resources. After releasing one of the connections back to the pool, it becomes available again and a subsequent request is able to reuse it, referring to the earlier example of the object pool pattern. This design is particularly advantageous in environments where creating new objects is expensive in terms of time or resources. It ensures that objects are reused, reducing the need for frequent creation and destruction, which can lead to significant performance improvements in resource intensive applications like database management systems or web servers. By managing object lifecycle and limiting the number of active instances, the object pool design pattern helps optimize resource utilization, making systems more efficient and scalable. To thread pooling in multi-threaded applications. In multi-threaded systems like web servers or game engines, managing a large number of concurrent tasks can be complex. The object pool design pattern is used to efficiently manage a pool of worker threads, allowing tasks to reuse existing threads rather than creating new ones for each request. This reduces the overhead of constantly creating and destroying threads, improving performance and resource utilization. By having a thread pool ready, tasks are executed faster and the system can handle more concurrent requests without running into resource bottlenecks. Why object pool design pattern? The object pool design pattern is useful because it promotes resource efficiency by using objects like threads instead of creating and destroying them repeatedly. This pattern helps maintain a fixed number of threads, allowing tasks to be executed efficiently without the overhead of constantly creating new threads. By limiting resource consumption and managing the number of threads, the pattern ensures that system resources are allocated effectively, enabling smooth performance even under heavy workloads. This approach helps prevent performance issues that can arise from excessive thread creation or resource exhaustion. Expanded use case. Imagine a web server that processes multiple client requests simultaneously, such as serving content to users. Instead of creating a new thread for each request, which can be resource heavy, the object pool design pattern manages a pool of reusable threads. This optimizes resource usage and allows the server to handle high traffic smoothly. For example, when a new request type like a file upload is introduced, the server can simply reuse an existing thread from the pool. The object pool pattern makes task handling more efficient without the overhead of constantly creating new threads. Practical implementation. In this example, we demonstrate the thread pool pattern using Python's concurrent.features.thread executor, which allows multiple tasks to be processed concurrently by a pool of threads. This is particularly useful in scenarios where multiple tasks or requests need to be handled simultaneously, such as handling web requests or I/O bound tasks. Similar to previous examples where resource management and efficiency were key. This pattern optimizes the handling of multiple tasks without creating a large number of threads or blocking execution. The handle underscore request function represents a simulated task that handles individual requests. Each request is assigned an ID and takes 2 seconds to process, simulated using time.sleep. The core of the implementation resides in the process underscore request underscore with underscore thread underscore pool function, where a thread pool is created with a specified maximum number of worker threads, in this case 5. This means that up to 5 requests can be processed concurrently, while additional requests are queued until threads become available. To process multiple tasks, 10 requests are created and submitted to the thread pool using executor.submit. This schedules the tasks for execution without blocking the main thread. By using concurrent.futures.as underscore completed, we can handle the results of the tasks as they complete. This ensures that once a thread has finished processing a request, the result is retrieved and any exceptions during execution are handled. The advantage of using a thread pool is that it controls the number of active threads, preventing the system from being overwhelmed by too many concurrent tasks. As soon as a thread finishes processing one request, it becomes available to handle the next one. This not only improves efficiency but also ensures that system resources are managed effectively. Referring to earlier examples of resource management such as the object pool design pattern, this approach ensures efficient use of system resources by using threads instead of creating new ones for every task. It is particularly useful in high-performance environments where tasks need to be processed in parallel, but without overwhelming the system with excessive thread creation. By controlling the number of threads and managing task execution, the thread pool pattern offers a scalable solution for processing concurrent tasks efficiently. 3. Object pooling for game entities. In video games, objects like bullets, enemies, or particles are constantly created and removed, which can be costly in terms of memory and performance. The object pool design pattern helps manage these entities by reusing objects from a pre-allocated pool instead of creating and destroying them repeatedly. This improves memory usage and ensures smoother gameplay by reducing the overhead of frequent object creation and garbage collection. The pattern allows game developers to efficiently recycle objects like bullets or enemies when they are no longer in use, optimizing resource management. Why object pool design pattern? The object pool design pattern is great for improving memory efficiency, especially when objects like bullets in a shooting game are created and destroyed frequently. Instead of constantly allocating and deallocating memory, objects are reused from a pool, reducing fragmentation. This boosts performance by reusing existing objects, minimizing the load on garbage collection. The pool also helps with better memory management, especially in environments with limited resources, such as mobile games, by ensuring objects are recycled rather than discarded. Expanded use case. Imagine a 2D shooting game where players or AI enemies fire bullets frequently. Instead of creating new bullet objects every time, the object pool design pattern uses inactive bullets from a pre-existing pool. When a player fires, the game retrieves a bullet from the pool, optimizing memory usage by avoiding constant object creation. After the bullet is used, it's returned to the pool for future reuse. If a new bullet type, such as an explosive round, is added, the pool can be extended with minimal changes to the game logic. This approach enhances performance by minimizing memory fragmentation and improving overall efficiency. Practical implementation. In this example, we see the object pool design pattern applied to manage reusable bullet objects in a shooting game. The pattern is particularly useful in scenarios where object creation and destruction are frequent and resource intensive, such as when bullets are continuously fired and reset. Instead of creating a new bullet each time one is fired, the game uses an object pool to recycle bullets, ensuring efficient memory and resource management. This approach is similar to the object pool examples we seen earlier, where we use a fixed number of objects to avoid the overhead of creating and destroying objects repeatedly. The bullet class represents a single bullet entity. Each bullet has an active state which determines whether it's in use or available. The fire method marks the bullet as active, simulating its use in the game, while the reset method deactivates it, making it ready to be reused. The bullet pool class manages a pool of bullets. When a bullet is needed, the get underscore bullet method checks the pool for an inactive bullet and activates it. If no inactive bullets are available, the pool signals that there are no more bullets left. Once a bullet has completed its task, it can be returned to the pool using the return underscore bullet method, which resets it for future use. In the example usage, we create a pool of 5 bullets, simulating the limited resources in a typical game environment. 3 bullets are fired and 1 is returned to the pool, demonstrating how the pool patiently manages the recycling of bullets. When a bullet is returned, it becomes available for reuse, ensuring that the game doesn't run out of bullets or require continuous creation of new ones. This pattern is essential in resource constrained environments like games where rapid creation and destruction of objects can lead to performance bottlenecks. By reusing bullets, we reduce the overhead of object instantiation, improving performance and reducing memory usage. This is a practical example of how the object pool pattern enhances system efficiency, as seen in similar scenarios with database connections and thread pools from earlier explanations. 4. Connection pooling for HTTP requests. In applications that make frequent HTTP requests, like APIs or web crawlers, maintaining a pool of reusable HTTP connections is crucial for performance. Instead of creating a new connection for each request, the object pool design pattern uses existing connections from a pool. This reduces the overhead of constantly opening and closing connections. By efficiently managing these resources, the application can handle higher loads, minimize latency, and optimize system performance. especially in scenarios with high traffic or repeated requests. Why object pool design pattern? Opening and closing HTTP connections takes time, but maintaining a pool of reusable connections avoids the overhead of creating new ones for every request. By reusing connections, the system uses network resources more efficiently and can handle more requests without creating new connections each time. Object pooling ensures that connections are managed properly, leading to faster response times and lower latency in network communication. Expanded use case. Imagine a system managing a large number of HTTP requests, like an API handling thousands of requests per minute. Instead of creating a new connection for each request, the object pool design pattern allows the system to reuse existing connection objects, boosting performance significantly. When a new secure request type, such as steps calls with authentication, is introduced, the system can be easily updated. The connection pooling logic simplifies the process, ensuring minimal changes are needed and avoiding the overhead of creating new connections for each request. Practical implementation. In this example, the object pool design pattern is applied to manage reusable HTTP connections using Python's request.session objects. The main idea behind the object pool pattern is to avoid the costly process of repeatedly creating and destroying objects by using a fixed set of resources. In this case, we are using the pattern to manage a pool of HTTP connections, which is particularly useful for applications that need to make multiple requests to the same server. By reusing session objects, we can take advantage of persistent connections, reducing the overhead of creating new connections for every request, and improving the performance and scalability of the system. The connection pool class creates a pool of reusable session objects which act as connections for making HTTP requests. Instead of creating a new connection for every request, the pool pre-fills itself with a set number of session objects defined by max underscore size. When a connection is needed, the get underscore connection method retrieves one from the pool, and after it is used, the connection is returned to the pool using the return underscore connection method. This ensures that connections are recycled, which is critical for performance, especially in scenarios where the number of requests is high. In the example, we create a pool of 5 connections and use one of the connections to make a GET request to an external API JSON placeholder. Once the request is completed and the response is printed, the connection is returned to the pool. This pattern ensures that we do not need to repeatedly open and close connections, which can be expensive in terms of time and system resources. Similar to the object pool pattern we explored earlier in contexts like database connections and bullet management in games. This implementation demonstrates how pooling resources can lead to more efficient and manageable systems. In high traffic environments where multiple HTTP requests are made, managing connections in a pool helps to reduce latency, improve response times, and optimize the usage system resources by reusing the same connections instead of constantly creating and tearing them down. This approach is particularly useful for web servers, APIs, and applications that require persistent communication with external services. 5. Resource pooling in distributed systems. In distributed systems, resources like CPU, memory, and storage are often shared by multiple services. The object pool design pattern helps manage these resources efficiently by using them instead of creating new ones every time. This ensures that resources are not over allocated, reducing system overhead and improving performance. For example, when a resource is no longer in use, it is returned to the pool for reuse by another service, ensuring optimal allocation and minimizing waste. Why object pool design pattern? The object pool design pattern is essential for managing limited resources like CPU, memory, or storage in distributed systems. It allows for efficient reuse of resources, ensuring they aren't over-allocated or wasted. By providing a shared pool, the system can handle multiple services competing for the same resources without causing bottlenecks. This pattern helps reduce system load by using available resources instead of continuously creating new ones, improving overall performance and preventing resource contention. Expanded use case. Imagine a cloud computing platform where virtual machines VMs are allocated dynamically to meet demand. By using the object pool pattern, a base VM configuration can be cloned and slightly adjusted to match specific resource needs for different tasks. If a new VM type like a high memory VM is introduced, the system can easily adapt with minimal changes. This pattern allows for efficient VM management, ensuring that new instances don't need to be provisioned from scratch each time, optimizing both speed and resource usage. Practical implementation. In this example, the object pool design pattern is applied to manage a pool of virtual machines VMs. This design pattern is particularly useful when we need to reuse expensive or limited resources like VMs system. Instead of creating new VMs every time one is needed, which would involve significant overhead, the object pool allows us to pre-create a fixed number of VMs and reuse them when needed. This ensures that we don't continuously allocate and deallocate, improving performance and improving partners' efficiency. The virtual machine class represents each individual VM with an in underscore use flag that tracks whether a specific VM is currently allocated. The allocate and release methods mark a VM as in use or available for reuse, simulating the process of allocating and releasing a VM in real-world systems. The virtual machine pool class manages a pool of VMs. It pre-populates the pool with a fixed number of VMs, 3 in this case, and allows users to request or release VMs. The get underscore VM method looks for an available VM and allocates it, while the release underscore VM method returns the VM back to the pool after use. If all VMs are in use, the system alerts the user that no more VMs are available. This approach is similar to previous object pool pattern examples like the connection pool or bullet pool, where we manage and recycle a limited number of reusable resources. Here, VMs are treated as resources that can be used once released, ensuring that no new VMs need to be created unless absolutely necessary. This greatly reduces resource overhead as each VM can be recycled multiple times. By using this pattern, we efficiently manage a limited set of resources, reducing the need for creating new VMs and optimizing the system's performance, especially in scenarios where rapid allocation and deallocation of resources are required, such as in cloud environments, data centers, or other infrastructure management systems. And that's a wrap on the object pool design pattern. Now you've got a solid understanding of how to reuse objects efficiently in Python, saving memory and improving performance. If you found this video helpful, don't forget to give it a thumbs up and subscribe for more Python design pattern tutorials. Thanks for watching, and I'll see you in the next video.